Hi, I'm recording a little setup information on to get Jupyter Lab up and running on Windows. To get started, you need to install Anaconda for Windows, which I've done. So if I hit this little Windows key and I type in Anaconda, you can see I get the Anaconda Navigator, the Anaconda prompt, and the Anaconda PowerShell prompt, all these things here. I'm going to click on the Anaconda prompt, and that pulls up on a different monitor. Here we go. That pulls up a Windows DOS prompt, instrumented properly for Anaconda. We can see on the left it says base. Actually, we can't see that. Let me see what's going on here. No, no. Oh yes, it does not appear to be properly configured here on my screen capture software. Let me see if I can't fix that with the properties here. Okay. Filters, crop, minus. Okay, so again, this is the command prompt, which I loaded by hitting the Windows key, typing in Anaconda, and I'm looking for the Anaconda prompt here. It's not the PowerShell prompt. It's just this regular Anaconda prompt. So whenever we work, we're going to work from a virtual environment. So if I type in conda env list, I can see all of the environments that have been created on this system. So there's a number of different tasks that I've done. I'm going to make a new environment called demo, and in order to do that, I just say conda create -n demo. And what's going to happen is it's going to create effectively a new installation of Python on my system that replaces whatever else I have installed. So if I say conda activate demo, just like it says in the instructions up there, then basically that replaces the old Python, my normal Anaconda Python, with this new Python environment. I'm going to clear the screen, and if I were to type in conda list, then it'll list all of the packages that are installed, and there are none. Python has two package managers. Conda has multiple, but Conda is a package manager that does pre-built packages, and those work well, especially on Windows. And then pip is good, especially for packages which are built from source. And here we've got almost nothing installed. It's telling me that that there's a warning and that I should use Python and pip. And it tells me how to upgrade. That's fine. I'll do that right now. That wasn't intended to be part of this video, but I'll go ahead and get that taken care of. Pip install. Great. Okay. So this is a classic problem that happens, and I think it especially happens on Windows when you've set Anaconda up for everybody, but you're a user. So when this permission error happens, just put --user at the end of your command, and instead of trying to install it to the system-wide place where you don't have permission to edit it, it'll install it under your home drive. So so basically, again, if I do pip list, we'll see that I have almost nothing installed. The warning's still there, but okay. So this is sort of like your vanilla environment. If I type in Python version, we can see which version of Python was installed in this new demo environment, and it was 3.7.4. I'm okay with that. So once I've got a virgin environment, then you kind of begin to set it up for the work that we're going to do. We tend to do scientific computing. So I'm going to use Anaconda to install libraries for scientific computing, and that's Scipy. And that'll install most of what we need. But there's a few extra things that we're going to want to have installed. We could do them one by one, or as I could list multiple things that I want here, but I'm going to do it one by one. If I hit enter, it's going to install that into this demo environment. It's going to ask me to confirm that I want to do it, and I'll say yes, and it downloads and installs all of these different packages. And if we look at what it's installing, it did upgrade pip. It's installing NumPy, which is the numeric Python. It installs the Visual Studio Runtime, Visual C++ to build packages. So there's a bunch of stuff that come with it, but not everything that we're going to want. So the other thing that we tend to want to do when we develop, I like to program in PyCharm, which I'm not going to dive into this on this one, but I also like to prototype ideas quickly using, for instance, Jupyter. So for that, you want to do conda install Jupyter, and I believe it's Jupyter Lab, right? So actually you can type in conda search Jupyter just to see what we can find, and it'll look for things that kind of keyword match that package, right? So I'm going to do conda install Jupyter, and I'll do a -y just so that it doesn't ask me the question. And I believe right now when I install Jupyter, it installs Jupyter and Jupyter Lab and pretty much everything that you would want. There's a few other things that we're going to need to install that don't come with this. So one of the beauty of Jupyter, if you don't already know, is that it's sort of this web-based user interface to Python that that looks it allows you to do all sorts of interactive stuff. But in order for that to work properly, I'm going to need to install some the IPy Matplotlib kind of libraries, right? So in order to do that, I looked up in a browser. Oh, here we go. All right, so in order to do that, well, first of all, let me just show you what Jupyter is. If I type in the word Jupyter, I'm in the demo environment, which means that the version of Jupyter that it runs is not going to be my system-wide version of Jupyter, which I probably got with Anaconda, but it's going to be the one that I just installed in this environment, right? And then I type in lab, and I see. So I need to install not just Jupyter, but Jupyter Lab is one word. In order to get the Jupyter Lab environment. I prefer to work in Jupyter Lab over than just plain old vanilla Jupyter. That gives me a few extra little perks, like I can use it more like an IDE. So once I've done that, I just type in Jupyter Lab, and it'll spin up a browser. It'll start a local web server and spin up a browser window over here, which I can actually stick to for the rest of this little video. The files that you see here are whatever folder you were in when you invoked Jupyter Lab. So I'll just try to change into maybe documents, projects, just make a new folder, demo. Right, so so it brings up a terminal. However, you might have had it prefigured for stuff. I have over here a Python console, over here a help window. So basically I can get help on whatever is going on in the Python. And then over here I've got a Windows PowerShell prompt. I'm not quite sure how to tell Jupyter to use a different prompt. I don't like PowerShell, just largely because I don't know how to use it. So I'm just going to write in cmd here and then cls. So that's the command prompt that we had before. And we're in, as you can see, the demo environment. I'm thinking that there's a way to tell it just not to even use PowerShell, but that would be something to look up another time. So good. Now the issue here is inside of here I can, if I hit the plus sign, for instance, I can create a new notebook that is a Jupyter notebook. And if you come here and you type in the word PyLab, let's say inline, and you hit Shift Enter, it'll try to load a plotting library, but we don't have one installed, right? So I'm going to come back here into the terminal, and I'm going to say conda install matplotlib, and I'll just do -y so that it doesn't ask me a question. And so Matplotlib is the kind of the default library that gets loaded when you use that little magic command pylab inline. So if I try this again, and by the way, pylab inline is probably a bad habit. What you really want to say is matplotlib inline, and that's an A. And then it doesn't. So the difference is that pylab cluttered my namespace with a bunch of stuff. It imported a bunch of things secretly, but so now there's no plot. So if I want to import the plot library now, I have to say from matplotlib.pylab, import plt. So now I can say plot.figure to create a new figure. Sorry, I just hurt my finger, so I keep accidentally hitting the wrong key because my knuckle's swollen. And I could say something like plot. I have to import NumPy as well, right? And so I should now be able to say something like plot np. I'm trying to type, but I can't hit the keys. np.linspace, let's say from 0 to 1 in 100 steps, right? And of course, it's inside that plot package. All right, so, and it shows, it pops up right in there in line. It doesn't know that I've got a dark theme here. Under settings, JupyterLab theme, you can change the theme. I kind of find this to be easy in my eyes, but of course it won't match the plots unless I were to say something like, what is it? I'm not quite sure what the command is. There's a way to set the background color of a plot, and I don't recall what it is. I'm going to guess a few times and then give up. How about over here? We've got the help automatically kind of shows up when you're working things over on the right, which is pretty nice. Some of the parameters, especially for the Matplotlib stuff, they're curried into this keyword args argument, and so in order to see them, you have to read through a lot of documentation or look online. It looks like what I'm looking for here is face color. There you go. So I can make it match my theme if I wanted to, but ooh, that's not good. So you can kind of get sucked into these things. You'll notice that the background is white. That's just because it's an axis. Face color blue. All right, so you've got different ways that you can kind of tune these things. Of course, the documentation is over here on the right if you bother to read it, or you can just go and Google online. You can, with most of these colors, I think that you can use hashtag kind of codes for them. Okay, so that's good. This little line of text here is the last statement that I executed. If I want to suppress it, I put a semicolon there. However, this plot is not interactive, and there's other libraries that you might want to install. So whenever you want to install a library, what I prefer to do is to go back to the prompt to install it, and then I'm going to use pip this time because this library is all from source, and I'm going to pip install tqitem, tqdm. And what tqitem is it's a pretty good progress bar library. And so if I were to come over here, and I was just to say, so for I in range, 100, sleep, let's say 0. I'm sorry, I can't hit the key. 0.1. My finger is really stiff. I think I need to import the sleep from time. So I'll come back up here, and I'll just from time import sleep. There we go. And then this is a slow loop. It takes a long time, and things become unresponsive. So what you can actually do is you can import tqitem.auto as tq. So the idea here is tqitem is a progress bar library, and there's a different version of a library to run inside of an interactive GUI like this, versus if you run it from the command line. If you run it from a command line and display the progress bars, it's done with ASCII art or ANSI characters. Inside of a notebook, it actually can pop up a widget, and if you import tqitem.auto, it'll pick the right thing. And I just give it a short name, just not to clutter my namespace. So instead of range 100, I can do tq.trange 100, and what happens is it automatically creates a progress bar widget to display inside of Matplotlib. You'll notice though that I don't see this progress bar widget, and so there's another step to the install process that we need to explain in order to kind of fix this. So over here, there's a couple of steps we need to do. One of them is, hold on a second, we need to install Node.js, right? So we can do that from here, conda, if we type in conda search Node.js. Remember, this is a web application, so it's going to use some JavaScript. I think that the version of Node.js that we really want to get is going to be from CondaForge, right? So if I type in conda install, and I just copied this from the internet, I typed in IPy MPL. This is where we're going. We're going to be installing Matplotlib for IPython, and I read the instructions, right? So there's a version of Node.js that's on CondaForge that we're going to want to install, and so before installing IPy NPL, I'm installing Node.js, and then once that's installed, I'm going to use yet another package manager. So for the little web application, which is Jupyter they have their own JavaScript package manager, which is Node. And using that, we're going to install the sort of the JavaScript libraries that it takes to get those widgets to display properly. We're not directly going to invoke npm or node. We're going to be using a Jupyter command, which behind the scenes is going to use node. So over here, we're going to say Jupyter lab extension install, and at this @ in the beginning, Jupyter widgets, Jupyter Lab Manager. And so what that actually does is it installs the JavaScript libraries which are necessary in order for you to get these kind of interactive widgets inside of Jupyter Lab. And since we just installed the latest version of Jupyter Lab, it's automatically going to try to detect that something's been installed and rebuild Jupyter. Otherwise, there's a command line option or terminal option to do it. So here we can see this is the JavaScript package manager trying to build all of these little JavaScript extensions, which are going to come over here and make it so that this HBox element gets rendered using JavaScript as something pretty rather than this unuseful, not so useful text. I'm going to go ahead and pause the recording because I think this takes a few minutes. Actually, while that's going, I wonder if you can kind of see why I can't type properly. I'm not sure if it'll be easy to show. This bent, swollen finger is supposed to look like this one, but it's all very much out of whack because I injured it on a rope swing. And I'm finding that I can't hit the keys on the keyboard anymore. So hopefully I'll work that one out. By the way, if you see me looking over there to talk to you, that's because in my recording software, the webcam is over there. So I'm just going to go ahead and hide the webcam again and put this on pause. All right, I went up to grab a soda, and it's still trying to build the asset. So I'm going to kill it. Take a quick peek at what happened. It's waiting for some lock to get acquired, so this is highly suspicious. So I'm going to try this again, but I'm going to pass a debug option to it, and I think that I'll get a little bit of extra output showing me what it's doing as it tries to build, so I can get a bit more of an indication of whether it's failing or whether it's just slow. And we can see here it's using Node to do some stuff. Let's see, Jupyter Lab staging, yarn, run, build, prod, minimize. So that seems to be where it's stuck now, huh? And so I have no faith. Oh, never mind. I was just about to say I have no faith in this actually finishing, but then it finished. So now if I come over here, and if I refresh the entire window, let's see if executing this thing works perfect. So it now shows a little widget for that progress bar as I go through. So this is going to be really good when we're doing these long-running, slow processes. And instead of doing a regular for loop, we can do a for loop using Ticaitum and get our feedback via these progress widgets nicely. Of course, you can look over here and see the T range has some other options. It's telling you right here that it's a shortcut for this function, which we might want to look up. If you ever want to look something up, you just put a question mark down here, and you could type in Ticaitum Ticaitum notebook. This probably won't work, but I'll fix it in a second. Ticaitum, right? And hit Shift Enter. Of course, it needs to be able to find that object, so I need to import Ticaitum.notebook first. And then you kind of get your help right here in the thing, and I can see that this Ticaitum thing takes anything which is iterable. You can pass all these other parameters like description, what the total should be. It does a good job of automatically detecting the totals, like in this case is 100, but you can do all kinds of stuff. And I'm not going to dwell on that too much other than just write description equals doing something. and I have to spell it properly. And so you can see you get a little description next to the progress bar, which is good. You get automatically these decorations on the side, and there's ways to customize that. One thing is, if I were to print something in here, it works nicely inside the Jupyter notebook, but when you're running it from a terminal, you probably don't want to do that. You probably want to use tq.takaitem.write, and then you can print something like that. Right? So it has the same result inside of the Jupyter notebook, but when you're running on a terminal, remember it's using ASCII art to print the progress bar. So generally you should try to use that when you're using these progress bars, but I don't want to do that either. So once I've got all of this installed, one thing that you can do with these widgets, let me get rid of that cell, is instead of doing Matplotlib inline, if I restart the notebook, I can do Matplotlib widget. And if I hit enter or shift enter, then it should display the interactive plots, but it can't because I need to install IPyMPL. So I'll just come over here, conda install, and if, of course, you look up the instructions on IPyMPL. They're over here. Those instructions tell you to install Node and to install Jupyter widgets, and then we just want to install IPyMPL. Now you can use either pip or conda. I'm going to go ahead and I'm going to use conda. All right, so conda install -c conda forge IPyMPL, and should ask me if I'm okay, and I'll say yes. And then I should be good. If I come back over here when that's done and try to re-execute that cell, no problem. And when I go to do the plot, I'll talk about a little wrinkle here. Well, it failed, right? I think I need to refresh the screen. And Jupyter automatically detects that a new JavaScript thing was installed and that it should be rebuilt. So I just hit the build button. It'll try to rebuild it, right? And then once that succeeds, I think I'll get a notification. Yeah, it can't really do it until that build finishes. So kind of in the background, it's doing a build. You can kind of manually trigger this by going to a terminal. I'm just typing the word Jupyter lab build. And the benefit of doing that is you can kind of see when it finishes. You get the little progress bar. Otherwise, it just happens in the background and you have no idea it's finished until something like this suddenly works, right? So let's let that one go through. I don't know why minimizing the JavaScript is taking so long. There's probably a way to get it to not minimize, but we just have to wait for that. And if you don't know what's going on here, like I said, there's a bunch of JavaScript libraries, but in order to save load time and refresh time on all these screens, JavaScript often goes through something which is similar to compilation. It's minimization, where they shorten the actual text of the JavaScript so it takes less time to load into your browser. Oh, here we go. Reload. So when you do it the previous way, not through that terminal, you get a little alert once the build finishes. When you do it through the terminal, you can actually see the build happen step by step. So what's better? I don't know. Let me restart the kernel. And execute these cells. Try that again. Restart the kernel. Execute the cell. Maybe because this is still going on. Okay. There we go. So now we plot the figure, and instead of being a static thing like it was before, this is now an interactive figure. I can pan, I can zoom, I can do stuff with it, right? So little caveat for that, of course, is that we're going to find that whenever we create a figure, we're going to want to give it a name. Conveniently, that name shows up above the figure. But another thing is it prevents us from accidentally creating duplicate figures all of the time. You'll notice when I went back and re-executed the cell, it kind of disappeared. If you want to, the best way that I know, and maybe you could tell me if there's a better way to get it to kind of like, well, maybe if we set clear equal true. Let's give that a try. Kind of like experimenting on this little video right now. Nope, that doesn't help either. So the best thing that I know is you have to close the figure before you reopen it, right? So I mean, basically the issue is this is an object that lives on in the background of your thing. And you know, when down here, if I were just to say something like maybe plot another line, what should I do? It went from 0 to 1. Let me do the cosine, right? So I'll get a nice little curve, and instead of plotting it below that cell, it goes back up and it plots it in the current figure, which might be up in a different cell. So that's one thing about once you're doing this Matplotlib widget thing. You can kind of build your plots elsewhere. It's useful sometimes, but if you want to kind of grab that figure by name, then you would come back here and say plot.figure. So I can make a new figure, or I can grab the previous figure if I use its name. So if I use its name, instead of creating a new figure, it just grabs that previous one and plots over it. So yeah, that's it. Okay, so and again, the next thing I guess is if we want to be doing deep learning, but I'll stop here. I think these are the big things that you want. There's other things that you need to install if you're going to do deep learning on the CPU, for instance, or whatever. You need to Google PyTorch and come down and find the right version that we've got. I don't have CUDA on this machine, and so this would be what I would install right here. And so that comes in here in the terminal. And you should be just about ready to try things with PyTorch and play with those. But I'll stop recording now.